So we now have, would you believe, 12 speakers. So it's going to be hard and fast, and we start off, I believe, with Mike Lynn and Thomas Keane. Is that right? Or just Mike? Thomas as well? Okay.
Thank you, Ewan, and I, for one, found the video very touching indeed. So. Just do it on here. This one. Okay. Good morning, everyone. I'll tell you a little about this morning about HTSget, which is one of the first technical protocols approved under the new Connect process that we've incubated over the past few years. It's a web protocol for accessing data over a web API in the kind of incumbent high throughput sequencing formats, that is BAM, CRAM, and VCF. It supports remote subsetting of those data sets by genomic range, so that either you can retrieve just a desired kind of genomic range slice of the data set, or you can, across many compute nodes in parallel, retrieve kind of the whole genome, but in a distributed and parallel fashion. And importantly, it suggests a uniform security and authentication layer for portable and interoperable delegation of security credentials across a variety of different either cloud or local services, so that we can have a kind of uniform authentication layer. Let me frame a little kind of how this fits in. Since the kind of the earliest days of the Global Alliance, there's been a recognition of some difficulties scaling up kind of the kind of high throughput computing world that many of us who came up in bioinformatics, running things on compute clusters and FTP servers and stuff, and how to kind of scale that to the really global setting of interoperable data sharing in the Global Alliance. And so it's been a long interest of the organization, whether from the data working group through to the large-scale genomics workstream today, to think about how can we move the field more towards some of the great kind of cloud-based and big data technologies that are kind of maintained by such a wide and diverse community of big data fields all over the world. But also we have to recognize there's a tremendous amount of data and a tremendous amount invested kind of in the existing infrastructure. So you can think of HTSget as sort of a bridge between these two worlds, allowing us to kind of evolve towards the right-hand side of the picture in a kind of smooth and graded fashion. So in particular, kind of like from a menu, we're choosing things from column A and column B, and that let us kind of put them together and move between them smoothly and try to both maintain compatibility with incumbent file formats and systems like FTP servers, but also allow a transition there to kind of to more modern web APIs, object stores, things like portable workflow languages, and Spark and Docker. I won't go too much into the technical details in this format, but HTSget has a specific web protocol that acts as kind of a redirect server. So there's a little lightweight server that receives a request for a particular data set and perhaps a genomic range, and essentially instructs the client to talk to another service, perhaps an FTP server, perhaps a cloud object store, or perhaps even an older parallel file system, on exactly how to retrieve that desired slice of the data. So by talking to HTSget, the HTSget protocol, and especially with regard to authentication, it provides an abstraction layer over whether it's a cloud backend or a file system or what, and lets the client retrieve just that bit. The security protocol is based on OAuth 2 bearer tokens, but again, there's this important subtlety of talking between the two services. There's an OAuth 2 token for the ticket server, but the backend server that's actually serving the bulk data might be a cloud object store with its own authentication mechanism. It might be an FTP server or an SFTP server with a different kind of login. So a very important property of the HTSget protocol is how it has a mechanism for delegating credentials to that backend service so that the client ultimately needs that OAuth2 bearer token, but then can retrieve on its own the backend specific security credentials. HTSget support is now built into the IGV.js genome browser, which is one of the modern ways you can see on the Exac and Nomad browsers, for example. So there's an HTSget client built in. For the command line geeks among us, HTSget client support is built into recent versions of SAM tools, 1.7 and up, and this is just showing some incantations for retrieving a slice of some NA12878 data, either from a server hosted at the Sanger or hosted by DNAnexus and Azure. Some other great things we can do with HTSget are, for example, driving parallel computation in a large batch workflow. So namely, when we have perhaps a whole genome sequencing data set in BAM or CRAM format, and we want to distribute perhaps a variant calling operation across many compute nodes, perhaps split by chromosome or something like that. So rather than having to kind of download a 100 or 200 gigabyte file and kind of slice that up and dispatch it off, HTSget allows all the worker nodes to kind of stream off just the piece they need. This is just a little slice of a whittle workflow that kind of shows what that looks like. It's just scattering across chromosomes or ranges, calling an HTSget client in SAM tools, perhaps calling a variant calling tool then, and that's just a kind of Gantt chart of an execution of such a workflow. First, using HTSget to retrieve a little slice and then processing it with a variant caller. I mentioned this kind of bridge to the future of big data technology, so I just showed kind of an example living in the old world of kind of batch processing on a compute cluster or something like that. The kind of parallel streaming features of HTSget are also very nicely compatible with a more modern big data environment like Apache Spark. So namely, with just a little bit of code in a Jupyter notebook talking to Spark or something, we can send out across a whole Spark cluster the logic to retrieve a little slice of read alignments from an HTSget service and logically kind of constitute that as one resilient distributed data set. Moreover, just using kind of plain vanilla Spark, once we have instantiated that, it's very easy to put a kind of SQL layer on top of that. Again, just another few lines of code, thanks to amazing kind of big data features that have been built into that across many fields. So there's a little, you can find the slides, I'm sure they'll be shared later, there's a little kind of demo of exactly what that looks like. But so again, an example of how with one service we can support both kind of more classical batch computation and these more modern big data environments. There's a number of server implementations, and we have a little interoperability matrix on the SAM Tools HTS specs repo there, where just across different server implementations, you can kind of click on an entry in this little matrix and get the little SAM Tools command line to just an example of how to fetch that data from each of those servers. Beyond the kind of server implementations of those of us directly involved in the work stream, there's more and more kind of community and developer effort on HTSget. So a lot of these organizations are all kind of either have it built into their products or are supporting it in some way or in the process of that. There's a short bioinformatics applications note that was published earlier this year, kind of just capturing the essence and providing like a citable form for the protocol. So do contact Rishi if you'd like to get involved. Again, the specification is fairly mature at this point. We're working through some pull requests, but it is past a 1.0. And really what we all want to see now is kind of more developer work and deployment of this as we think it's pretty ready to go. So with that, I will hand it to Thomas for splitting this time slot, and he'll discuss some of the work going on at DNA.